Hi, and welcome back to this series on how to view the world as information instead of matter. This is video number 2 in the series, and it's the B side, so to speak, to the introduction. Each topic in the video in the series, I'll do 2 videos on. The A video will have all the primary content that I want to get across. In the B video, I'll do a little bit later, and it will have any information that I forgot or supplementary information. Maybe people have asked questions, and sometimes there's more advanced material that I wouldn't want to include in the primary video. So you can get an overview of the topic by just watching the A videos, and you can get it more in depth by watching the A and the B videos. So this is the B video for for the introduction, really. So as a reminder, the video is about how we can think of the world in terms of information instead of matter moving it, which stores information. It's really hard for our brains to do that, or at least it was for me. It took me a long time to where I wasn't thinking about matter moving and it stores information. Think about all the properties that matter has that we can store information. It could be the position of a lantern, maybe, or an SSD cards that store files. It could be the position of ions around the transistor. It could be the configuration of ink molecules on a piece of paper that show handwriting or a drawing or a photograph. It could be the movement of air molecules that carry the sound waves that give us the information about what the person just said or what things have happened around us. Ultimately, we want to be able to let go of the view. We want to be able to let go of the matter. Just think about the information. So what are all the properties of matter that can store information? Its color, its size, its shape, its position, its orientation. But what about all the properties that can't store information? What properties do objects have that we couldn't use to send some kind of signal? Well, maybe you can think of the property that stars have of which stars have been blessed by a shaman. I don't think you can store information. I don't think you could study the stars and and detect which ones have been blessed by a shaman and get some information out of it. But that's not a real property of the stars. Anything that's an actual property uh, is a state, and the states are information. And if there are properties that can't store information, they're not real. So that just leaves us with the matter, with um, with the properties. That just leaves us with the properties, and the matter is superfluous. You could say, yeah, there's all this information properties, but there's also some matter there, and that's fine. But how would you detect it? All you can detect is the information you're getting. You might think, oh, yeah, at the subatomic level, there's electrons. Electrons at the subatomic level are just waves, really. They're probability waves, and uh, those particles are represented by just a handful of numbers and the numbers represent the quantum state. I think it's like 8 numbers. So you might say, okay, yeah, those numbers are the quantum state, but also there's like a little pellet. Well, how would it be any different? You can't detect the pellet other than by the information you're getting. So the world with a little pellet plus the 8 things is no different than just the quantum states. Same for non-quantum states. So you could say there's a little pellet in addition to the wave and all that, but it doesn't change anything. It doesn't help. James Maxwell, when he was inventing the equations for electromagnetism, he actually had a mechanical description. He kind of at first described it in terms of all these gears that sort of pervade the air, pervade space, and to get it to work, in between all the gears there are these little flywheels, and they're all like this. And he had that mechanical model, and it actually helped him to make the equations. It kind of worked. But once he had the equations, he let go of the matter behind him and just had the equations. Just um, and if you don't do that, then you could have to answer a whole other set of questions like, okay, what are these gears made out of? Can we whack them? Why can't we see them? Can we make them visible? Can we break these gears? What properties do the gears have? So so we kind of just have to let it go and say there's not a mechanical thing behind it. It's just it's just the properties. It's just the equations. And Maxwell let it go. After that paper, he never talked about the gears anymore. He just had the equations. The gears didn't do anything. So that's a real brief overview of the project. We're gonna get to a lot more detail. It's gonna be a lot more concrete than just that. But there's one other thing I wanted to do in this video, and that is I get asked sometimes if this view of the world as information is that a postmodern view? And there's different kinds of postmodernism. So in a way, you can't say. Um, there's really, on the one hand, there's very radical postmodernism where everything is relative. Maybe everything is a social construct or a psychological construct, and there's no central interpretation you can grab onto. And if that's what you mean by postmodernism, then yeah, this is that. It's a very radically uh, relativistic, and in fact, even things that you would say, oh well, it's solid matter, that's a table, turn out to be relative. I'll give you an example. Um, we've been hearing a lot about something that might exist called dark matter recently, and one of the dark matter basically just passes right through our matter. It doesn't interact with it at all, or if it does, it's very rare. So mostly can just pass right through the whole planet without interacting with a single atom, as far as I understand it. Let's imagine, and actually this is the theory, that dark matter particles can interact with each other. Dark matter particles can interact with other dark matter particles. So if that's true, or just imagine something similar, there could be planets made out of dark matter, and those planets could have people made out of dark matter, and those people could have houses and tables, and those tables would be solid to them. It would seem like matter. It's hard. It holds things up. It's reliable. You can put things on it. But to us, it's just a cloud of. It's not even a cloud. It's almost nothing. It goes right through us. We can hardly detect it. We can't detect it actually right now. So to us, from our perspective, that's not a table. So, but the interesting thing is that uh, to the dark matter people, our solidity is dark matter to them. Our tables are just, they pass right through them. It's not real. It's just a radiation gas or something. Another good example is think about last time I think we mentioned briefly the idea of take a game and make the non-player characters conscious. They would think they're in a 3D world. They would have tables. Those tables would be solid. They would hold things up. In fact, they might be completely indestructible. Um, and uh, and it really seems real. If they were conscious, that would really seem real to them. And from our perspective, when we're not playing, it's just information flowing around in the computer, and that's what they are. And so, information can perceive other information as being solid, but only in certain situations. We can't perceive the dark matter as solid, or the game matter as solid, unless we're playing the game, and it's kind of a little different. But so the information view represents the world that way. So in that sense, it's a very radically postmodern, or it's very radically relative. There's really no sort of uninterpreted view that you can get. The most uninterpreted view you could get would be to say, oh yeah, the universe is in state one, now it's in state two, now it's in state three, now it's in state four. That's about the least amount of interpretation you could get, and that's still from a frame of reference. But anyhow, that's also kind of a useless interpretation. So um, now something that's not postmodern is that this view is, I can't decide that I'm just going to be a dark matter person. I'd have to change the the constituents of my body. I have to take my atoms and change them out for dark matter atoms, if that's even possible. So solidity isn't a social construct. It has to do with the way that we interact with with the information structures that we call matter, and it's not a psychological construct. Now, that doesn't mean that there aren't such things in the information worldview. In fact, they're perfect examples of the relativism, because you always have to say it's relative to this or relative to that. So it definitely will represent the fact that some things are psychological constructs. If I say chocolate is tasty, uh, that's true to me. Or if I say hard work is important, that's true in certain social groups. Uh, Now, you can always take something that's relative and absolutize it by indexing an observer or a type of observer. So in Einstein's relativity, you can say, from a certain frame of reference, and then nothing's relative anymore. It's absolute if you give the frame of reference. And similarly, you'll find out that in the information worldview, we can always index an observer. So I can say to people like me, this is the solid table. To the dark matter people, theirs is a solid table. Or to the game people, to me, chocolate is tasty. Um, so you can always define your observer system, and then you've unrelativized it all. You say, but it's still relative to this, whatever. So it's a radical view in the sense that everything's relative, but it's not so. But it's not everything's relative, and even those things that are can be experimented on. You can actually take it apart and say, what's the difference between a psychological construct and a physical construct and a social construct, and do some math. We'll be able to do math on those. So it's kind of cool. So uh, that's pretty much it for this video. And the next video is going to be on the history of how we got where we are today. So some philosophy, and basically leading up to where we are today. How did we get this view of information or objects? How we have an object-oriented way of viewing the world right now. So how did we get there? That's going to be really important if you want to understand the full context, and if you really want to understand it, you need to know the context. You can't know what's different in your views if you don't know what your views are right now. So until then, I will see you later.